Hi everyone. So today we are going to discuss week 10 practice assignment. Have you guys seen week 10 videos? Am I audible? Can anyone confirm? Hello.
Yes, sir.
Yeah. Okay. Let me share my screen. I hope my screen is visible. How many of you have seen it? Week 10? Can you just raise your hand?
Yes, sir. Hello.
Yeah. How many of you have seen week 10 lectures? Can you please raise your hands?
No, sir. I have not seen the 10 lecture.
Okay. What about others? Rahul, Raz, Bharat, Pratyusha. Have you guys seen week 10 lectures?
No, sir.
Okay, okay. Okay, so the data set is mostly the same. So we will try to solve some of the questions. And if we are able to solve one or two questions, then I'll proceed. Otherwise, if you have any doubts, then we can discuss those doubts and wrap up the session. Okay. So in week 10, again, we are discussing matrices. Week 9 was also related to matrices. So here we are again. Let me open the PDF version of this. You are familiar with the data set, right? The train data set and other data sets. So I'm not opening that. Just keep the data set in mind and we'll try to solve some of the questions. Okay. Question number 1 and 2 are basically comprehension based questions, and we have some comprehension given, and based on that, we will try to do question number 1 and 2. Consider the following condensed version of the trains dataset. There are a total of n stations with uh, stations being indexed from 0 to n minus 1. So uh, the sequence number is basically for your trains. There are m rows in the table. Each row contains information about a train that connects two stations. Okay, that is different. That connects two stations without any stops in between. So sequence numbers are basically suppose we have train 1200 12,259 and it is departing uh, on day one and arriving on some station on day two, and total distance between the departure and arrival is 266. So that is your data. For example, the Earth row tells that train T departs from station I and arrives at station J after covering a distance of d kilometers without stopping at any intermediate station. In other words, the Earth row in this table corresponds to two consecutive rows in the card for train T in the train's dataset. Therefore, each train T will occupy multiple rows in this table. This scenario is modeled as a graph and represented by a matrix A each node in the graph corresponds to a station. Assume that the value of n is given, already given to you. Consider the following pseudocode. Okay, so now we have some pseudocode, and we are trying to populate okay, over here. We have initialized a dictionary, and we are trying to populate that dictionary using this step. So at the end of executing this part, what will s contain? Can anyone tell? So after executing this part, what
Yes.
will s hold?
Train data set.
So s will hold the details for trains. That is
Mm.
correct. So the keys will be what? Keys will be the sequence number of the train. Suppose we have train one. Okay.
Yes, sir.
Uh, this is not train. This is sequence number that is given in the here. Over here we have given some sequence number, right? So that we are keeping as the key of the dictionary. Then we have train. So inside this we will have another dictionary. Anyone saying anything? Okay. Then inside that we will assign train is equal to number of the train. So this is the number of train. So one, two, and whatever we have. So we will keep that. And then we have departure, which is this part. So we will have D. D will have the departure station. Then we have arrival over here in line number 7. We are initializing that. So this will be there. Then we have distance. So let's say small d. The small d is basically distance. And for first row, we will have this kind of data. Okay. So after iterating over this whole table, basically we will have the keys from 0 to m minus 1, and it will be mapped to the respective train, departure station, arrival station, and total distance between the stations. So that data will be populated in your S dictionary. Okay, so that is S. What about create matrix?
Yeah.
Is this part clear? What will S represent?
Yes, sir. Yes, sir.
Okay. If that is clear, then what about A? What are we trying to get in A?
Arrival time of the train.
So we are creating some matrix, right?
Yes, sir. Sir, row A is arrival time.
Could you repeat that again? You're not clear. What will A represent? Anyone?
Yes,
What is A? Create matrix of n, comma n.
okay.
So A is basically here we are creating A, and if you see this part, this will create empty matrix, right? So we will.
Yes, sir.
This is not how we represent matrix, but just to show you guys, I'm creating like this. And inside this, we will have empty dictionaries. Okay. So we will have empty dictionaries inside this. Okay. So that is our A. Initially, we have this in A, and here if you see, these are the three things. So first we are iterating over the rows. So first rows are this, columns are this. So for R in rows of A. So first we will pick the first row, and inside this we have to pick all the columns. So first we will pick, first column. I'm using one based indexing. So this particular cell, in that cell, we are saying that A of this over this over here, we are saying that it is an empty dictionary. Then we will move to the next cell, that is this. We will again do same thing. So using this, we are just initializing our A matrix, and after that we have some other step that will put some value inside your A matrix. Okay, got it?
Yes, sir.
Now for each X in keys of S, we are doing S of this. So S we created over here, if you remember. Okay,
Sir.
so what is X? Can anyone tell what is X?
Keys in S. Key,
S is
uh,
X is what?
key values in S.
X is basically serial number. So if you remember, when we created S over here, when we used this part, we got this kind of format, and then internally we had serial number, right?
Yes, sir.
And this was mapped to train. Train was represented using extra train, so some train number 147 maybe, so some train number. Then we had your departure station. Okay, so station number, if you see, we had some station number. So for the row, for the first row, we had this. Okay,
Mm,
so maybe let's take this only. Then arrival station, and
One
then total distance. So distance we used a small d.
180.
For distance we used a small d. So this is the format of your S, right? So if
Yes,
we
sir.
do for X in S, we are picking what? The
Sequence
key,
number.
the serial number, okay,
Yes,
or sequence number, you can say. So that is your X. Now over here, what will R hold?
departure time.
Departure station, not time.
Yes, sir. Departure
So if
station.
you check the table, we have departure and arrival contains the train, station number. So some kind of number, and that number is representing your station. Okay.
Okay.
So R will basically hold some,
Departure station.
yeah, departure
Mm.
station. I'm just saying capital D. What will C hold?
Arrival station.
Arrival station. What is T?
Train number.
T is your train number. Let's say 12125. Some train number. Okay, 5 digits. And what is D?
Distance traveled by the train.
D is your distance that we were using earlier. Now we are saying A of R of C of T is equal to D. What will this do? What will this do?
Store the distance.
So we created a matrix A, if you remember, right?
Yes, sir.
And that matrix, like, let me draw
Empty,
that matrix again.
empty matrix.
Sorry.
Empty matrix.
Yeah, this was basically a matrix and it has empty dictionaries, right?
Yes, sir.
This part is basically accessing what? The empty dictionary, right?
Yes, sir.
This part is accessing the empty dictionary. Then we are saying T is equal to D. So inside that dictionary, we are populating. Key will become your T, and we are assigning D there.
Okay.
Okay.
Yes, sir.
What is T? T was your train.
Mm,
Got it?
yes, sir.
Is the structure clear?
Yes, sir.
Okay. Others, any doubt? If not, I'll move to the questions. Okay. So if ij is a pair of stations, which of the following statements about the dictionary ij are true? Yeah, this one is an MSQ, so we may have multiple correct answers. Okay. So sorry. These are the options. Which one do you think is the correct one and why? And this is an MSQ, so we may have multiple correct options. So which of the following do you think are correct and why do you think those are correct?
Yes, sir. Mm,
Anyone?
A or C.
A and C, by mistake have already shown the answer.
Yes,
So
yes,
could
yes.
you explain why
I
A is
can tell the
correct?
reasons.
Why is A correct?
Sir, because we are I and J a pair of strings between the two stations. It means without any intermediate stations. We are checking the total distance between two stations in a matrix.
Okay. Okay. So how are you inferring that? So
Um,
how are you inferring like we discussed that like let me show that code again. Over here we are creating your dictionary sorry matrix, right?
empty dictionary, empty matrix.
Yeah, so we are creating a matrix and each element in that matrix is basically an empty dictionary, right?
Yes, sir.
So how do you know that the I and J, basically the rows and columns are representing your station? So
Rows
is
and
this part
columns
making
are
that clear, or there is something else in the code that you are using to infer that
no, it is clear that R and C are departure station and arrival station.
over here?
In the last line, we are assigning the departure and arrival station train number to the distance.
Okay.
So,
So from line
we
number
are just
20 and
checking
21
the
here.
distance between departure station and arrival station.
So from line number 20 and 21, you are inferring that R is basically your
Yes,
rows
sir.
are basically your station and columns are also a station.
Yes, sir.
Okay.
And in line number 24, we are assigning T equal to D and checking the distance between only departure station and arrival station.
Okay. Okay.
Is it correct?
Yeah, that is correct. What about option B? Why is it incorrect?
because it is said that it is stop at multiple stations between I and J, but we are not storing the distance between multiple stations. We are storing only distance between arrival and departure station.
Okay. What about C?
See, sir, as we discussed that we are assigning t to the distance between the departure and arrival station in line number 24.
Yeah, that is fine. What is T?
T is the train number.
Okay, T is your train number. So inside A, basically each cell will be of kind of this format where T is your train number and then you have some distance for that train. Okay, let's say T1.
Yes, sir.
Then you will have T2.
Yes, sir.
It will have distance D2, something like
Yes,
this.
sir.
Okay, so each element of the matrix will be of this format.
Yes, sir.
Okay. What about option D?
Yes, sir. It is saying that the minimum distance, but in the whole code we are not checking the minimum distance between any two stations.
Okay, yeah. We are not checking any minimum distance, so that is correct. Okay, so D is incorrect. Any doubt in this one? Anyone?
No, sir.
Okay, then we have question number 2. It is related to the previous comprehension. So what does the value length of keys of A of ij represent? What do you think? What will be the answer for
Mm,
this one?
B,
Sorry?
B.
Option B. Okay, why do you think it is B, not A,
And
C, or D?
because it is intermediate stations, and in the whole code there is we are not matrix. It is we are not storing any intermediate station distance.
Okay, okay. What about C? C also looks
C,
similar to B.
because it is J to I, but we are checking the length of I to J.
Okay, okay. So this was pretty simple. We are basically uh, we have the
And the
answer.
A and D
So
is incorrect because it is mentioned the intermediate station.
yeah. So we are basically I showed the format just now. Like each cell will be of this format. So T is your train number, and then you have some distance, and this distance is basically what? So
Distance
T1
between two
basically
stations. Okay.
train 1
300 forward.
is taking is covering this much distance
Yes, sir.
to travel from your station 0 to 1. So that is what this is showing. And your 0 is what? 0 is your some station I, and your 1 is what? Some station J.
J.
So this is your correct option. Okay. Okay. Any doubt in this one? If not, I'll move to the next question.
No, sir, I don't have any doubt.
Okay. Now we have question number 3. Okay. Okay, there are some more options. So, IJ is the processor that accepts a pair of stations and the matrix A as input. It returns a train which goes from I to J by covering the least distance without stopping at any intermediate station. If there is no train connecting these two stations, the procedure returns -1. The pseudocode may have mistakes. Identify all of them. This one is also an escape. Okay, so basically, IJMin is representing IJMin is a procedure that accepts. So we have a procedure defined over here. Okay, so this is our whole procedure, and it is taking two things. So it is taking station I and J. So these are the two pairs of station, and it is then taking what? A. A is what?
Matrix, matrix,
A is an
matrix.
A is a matrix. Okay, and it is trying to return a train that goes from I to J. Okay, by covering the least distance. Okay, so distance will be d min. Okay, between those station, and it won't stop at any intermediate station. And if there is no train between IJ, which is following this, then we will return -1. Okay. Now this pseudocode may have some mistakes, so we have to identify whether there are mistakes or not. If there are, we have to tell the line numbers. Okay.
Okay.
So first of all, we will check line number 2 and 3. So it is saying if length of keys of I j is equal to 0, return false. So is this correct or incorrect?
Line number 3, it should return -1, no?
Yeah, it should return -1, but here we are returning false.
False.
So this is incorrect. So option A is correct, right?
Yes, sir.
Now, in line number 5, we are saying train is equal to first of keys of A of ij. Okay.
Yes, sir.
So what do you think? Line number 5, is it correct or incorrect?
And first key means it is taking the if there is multiple train between I and J, it is taking the first train from I and
Yeah,
J.
yeah.
I think it is correct because we have to check the minimum distance. So we have to compare it from other trains.
Okay, so we are just trying to initialize using the first train in the what matrix, right?
Yes,
For
sir.
specific stations. Okay, that
Yes,
is fine. Now we are assigning the minimum distance, right?
yes,
This is basically trying to pick the minimum distance.
yes, sir.
Okay. Now we are doing the iteration over here. So is there anything wrong in the iteration, or is the iteration correct?
It is the distance. Distance is less than minimum distance from equal to 10. Sir, I think it is correct because it is taking the distance between two stations in each value in a row, k row, and then comparing the distance with the minimum distance we assign in line number 6. And if distance is less than minimum, then it is assigning minimum to the distance and train to the k.
Okay, so is this correct or is this incorrect?
I think correct.
So you think this is correct? Okay, so that means only option A is incorrect, and other than that, all the line number 3 is incorrect. Other than that, all the lines are correct, right?
Yes, sir.
But if you see this part, line number 7,
Yes, sir.
so first of all, A is your what? A is a dictionary. A is a matrix, right? That is
Yes,
given
sir.
in your question.
Yes, sir.
If we say this, what is this? What is the data type for this one? Is it a matrix, a list, a dictionary, a string? What?
Dictionary?
This is a dictionary, right?
Yes, sir.
Now, if this is a dictionary, we don't have the concept of rows and columns in a dictionary. Do we have?
Yes, sir. No, sir.
We don't have. So this particular thing is incorrect, right? We should
Yes,
have
sir.
said keys of
A.
this thing, right? Keys of this thing. We are already doing that over here, right?
A.
So line number 7 is also incorrect.
Yes, sir.
Here,
Yes, sir.
okay. So you have to like for each line, you have to also keep in mind the data type of the variables you are using. Okay.
Yes, sir.
So line number 3 is incorrect and line number 7 is also incorrect. Yeah. Any question? Okay. So line number, any questions? Do we have any questions?
No, sir.
Okay. There is some background noise, I think, on your side. Okay.
Five.
Line number 3 and 7 are incorrect, and other than that, all the lines are correct. So option A and D.
Line 5 is
Any doubt? So A and D are your answers. Okay. Line number 7 was incorrect because we over here we are treating A of ij as a matrix, but that is a dictionary. So that is incorrect. And over here in the question itself, we have mentioned that if there are no trains which are running from station I to J, then we have to return -1. But in the pseudocode, we are returning false. So that is also incorrect. So line number 3 and 7, option A and D.
line 5.
Line what?
5.
Line 5 is correct, no? Line 5 is correct. Why do you think line 5 is incorrect?
E returns value.
Line 5 returns value. You're talking about this?
Yes.
So, uh, okay. Suppose we try to access what we have in a cell. Okay. So this is basically, this will basically give us the content of the cell ij, right? Ith column and
Yes.
jth. So this will contain what? Train number, let's say T1, I'm saying T1, and then D1. Okay. So this is one thing. Then we may have train 2, D2, okay, train 3, D3. This is generic, not specific to this particular problem, okay. When we say keys of A of ij, we are picking these things, right? So keys of A of ij, let's say keys of A of ij will be what? It will be a list and it will contain all the keys. T1, then we have T2, then we have T3. Okay. So these are our keys, right? Now we are saying in line number 5, we are saying first of keys of this. So first of keys of this is T1, right? So we are saying that train we are initializing at train is equal to T1. So what is wrong in this? This is correct, right?
Yes.
We are just trying to initialize. And in the next line, in line number 6, we are just saying we have picked a train. Okay. We have picked a train T1. And whatever is the distance d1 is for that one. We are saying that min is what? Min is our d1. And then we are doing the iteration, and if we find that for t2 the distance is smaller, then your train will change to t2. If this particular thing is correct, it is not right now, but if we correct this, then at the end of the execution, if t2 has the minimum distance, train will contain t2, and our min will become what? Min will be d2, right? Is this clear?
Yes, sir.
Okay, so for this one, option A and D are correct. All the other options are incorrect. Mm, okay, there are many options. So, question number 4. We have a statement, let ij be a pair of stations. Which of the following statements are true about executing the pseudocode given below? Okay, so we again have a matrix A. Okay, we are doing some operation, and at the end we will have some result, and based on that result we have to pick the correct options. Again, this is an MSQ, so we may have multiple correct options. First of all, what we are trying to do here, and first let's try to decode what we are doing in first 4 lines. Okay, from here to here. When is I to j 0? Sorry, false. Initially it is false, and then we are switching it to true. What is the condition for switching it to true?
It should have a not equal to 0.
Yeah, keys of this particular thing is not equal to 0. So that means if there is
A train.
one train, at least one train, then we will have, sorry, true. Otherwise, we will have false. If there are any number of trains, we will have true. Otherwise, we will have false. Same thing we are doing for J to I, right? If there is a train between J to I, the value will be true. Otherwise, it will be false, right?
Yes, sir.
What about this one?
If both true, then I both j return true.
Repeat that again. What did you say?
If I to j is true and j to I is true, then I both j
When will
will be
I both
true.
J be true?
I to j, I to j and j to I true.
Yeah,
Then
so we
I
have
both
a
j will be true.
train in both directions,
Then
then
I
it will
both
be true.
j true.
Otherwise, it will be false,
False.
right?
Yes,
Okay,
sir.
now we have to pick the options. So, which are the correct options? Option A, is it correct or incorrect?
No, sir. It is incorrect.
Option A is incorrect. Okay. Option B.
It is correct, sir. Both is true, then I both j will be true.
Okay. What about C?
Uh, it will be true, sir. I mean, it will
Yeah,
be
I
correct.
both J is true, then the other two,
This both
this
must be
and this.
true.
Yeah. What about D?
It may be true, sir, because if one of if suppose if I to j is false and j to I is true, then I both j will be false. So it is not compulsory for both to be false. So I both j will be false.
So, what do you think? Is it correct or incorrect? Option A is correct
It,
or incorrect?
it is correct, sir. If both is false, then I both j will also be false.
It is Like we can't say, right? If this is
Yes, sir,
given, you can't
we can't say,
directly
sir.
say,
We can't say.
yeah, if I both j is false, we can't say that it is false
Both.
because the other twos are false. We can't say
Yes,
that,
sir.
right?
Yes, sir.
So this is incorrect because we can't say, there is not much information given. So we can't say that this is true. Again, option E is same thing. We can't directly say because
Okay.
again the same reason. Let's go to option F, and we have G as well. Do we have any other option? No, that's it. Okay,
Option
what
G
about F?
can be true. Sorry, will option G is true because it is or not and in option
Yeah,
G.
so this is correct. This is incorrect.
Okay.
This is incorrect.
Because it
This,
gives and it means both option is true.
yeah. So we have three correct options: B,
Yes,
C,
sir.
and G. Right?
Yes, sir. Yes, sir.
Okay. Any doubt in this one?
No, sir.
B, C, and G. We have three options. Okay. Now we again have, okay, so it again has some four, five or six options. We again have a procedure, and it is taking three things: train, station, and a matrix A that was computed in the previous question. So we had A computed in the previous question. Okay, so we are using the same thing. Which of the following statements about its return value are true? Okay, so which of the options are correct? Again, this is an MSQ. So let's see. First, try to decode what is given in the procedure, what we are trying to achieve using the procedure, and once that is done, then we will move to our options. So over here in line number 2, we are iterating over each row.
Yes, sir.
What does the row contain? So what does each row of A represent?
Each row of represent departure station and arrival stations of all trains between two stations.
So yeah, row is basically one station. Rows are representing the departure station, and your columns are representing your arrival stations, right?
Yes, sir.
So we are picking all the departure stations, and then we are doing an if, and if is basically checking in the departure station. So
If the
when we
station,
say this, what does this mean?
if there is an uh, departure station,
Oh, one second. Give me one second. Yeah. Okay. Let me go back to that screen. Okay. So over in line number 3, we are saying A of R of station. What does this mean? What will this return? A of R of station.
station, station number,
Station number. No, it will not return station number.
station.
A of R is what?
A of I is arrival station.
A of R is a list of arrival stations, right?
Yes.
List of arrival stations. Arrival. stations. Okay,
Yes, sir.
and then we are we already have a station given. We are passing that station. Okay, so if we
Yes, sir.
pass that, A is a matrix, right?
Yes, sir.
So this will return what?
Uh, True or false?
No, not
Yes,
true or
sir.
false. Think again.
In line number three.
In line number three. In line number three, we have this particular thing.
R of
So we are
R
trying
of
to
C.
decode what is that.
So,
What will that return?
A of R of station.
Yeah.
Um, Sir, A of R store the list of all stations. So A of R of station, I think will return the one by one each station.
So in the matrix, the rows are representing what? Arrival station.
Yes, sir.
Oh, sorry, departed station, and rows are your departure station, not your arrival station. And your columns, this is representing your arrival station, right?
Okay, sir.
Now, if we try to do this particular thing, so we are basically picking one cell, right?
Yes, sir.
And that cell is for which
Station.
the station is STN, the given station.
Yes, sir.
Okay. So
So for
suppose,
entire row, it means in a matrix from an entire row, we are picking one cell.
yeah, we are picking one cell, and that cell will contain a dictionary. And that dictionary was mapped to
Train and distance.
train to
Distance.
something, right?
Yes, sir.
Right.
Yes, sir.
So what are we trying to check here in line number three? What are we checking?
If there is a train in that cell,
Not any train, the given train. We are
yes, sir.
already passing a train. Okay. We
Yes,
are
sir.
checking
Basically, if this
whether
train was
the
in that
given
cell,
train is in that particular cell or not.
no.
We are checking that.
Yes, sir.
Okay. If it is not there, then we won't execute our if statement and we will directly return false.
Yes,
Okay.
sir.
If it is there, what we will do?
We will check for arrival stations if the train also there.
Then we are checking in
Yes, sir.
columns of A.
Yes,
Okay.
sir.
First we did in rows, then
Yes,
we are
sir.
checking in columns.
Yes, sir.
And if we found that it is again in some columns,
We
then we
will
are
return
returning
false. False.
false. So if it is in both row and column, then we are returning false. Otherwise, we are returning true.
Yes, sir.
Okay. So what does that mean? If we now try to pick the
The
correct
train is
option,
only from the in departure station. The train is starting only from the departure station. I mean C, C no sir, R from R
what are
station. The train is starting from R station.
okay? Train is starting from station R, but
Yes, sir.
uh, we again have return false as well. Over
Yes,
here
sir.
we have return false as well. So when will we return false?
If the train is also the same train is also running from C.
Okay. Okay. So let's say what
Sir,
about option A is
why in first if condition it is written A of R of station and second if condition A of station of C?
A of a station of C. So when we say Like if you remember, when we have to access the row,
Yes,
we
sir.
use this position, right?
Yes, sir.
And when we have to access column, we use this position, right?
Yes, sir. Yes, sir.
So in this line, when we are saying A of R of station,
Yes, sir.
R is what? R is your row and station is your
Column.
column. When we are saying this part, now station is fixed
Yes, sir.
and that is your row. We are fixing the row that we will just check in this particular row. Okay. And that row is station and we are iterating over the columns.
Yes, sir.
Got it?
Yes, sir. Yes, sir. Now I got
Okay.
it.
And in line number 3, we are fixing the column. We are saying that whichever column has a station, we'll fix that and we will iterate over all the rows.
Yes, sir.
Okay.
We will go through one by one station.
Yeah. Okay. So option A, is it correct or incorrect?
And we come to if station is starting from train. Station is starting from train. Sir, how does the station only start from a train? Train has to be started from the station.
Yeah, that is the same thing. Like train is starting from station STN, so that is same thing. Whatever your
It is not
question is saying.
mentioning if it is from R or C.
It's from R or C. R is your rows
It is
and
in option. In option.
repeat that again.
In option, suppose it is written to, it means it's running from a station.
Running from station. In option A, it is saying that some proc will return true if a station is starting station for
It will be
train.
true, sir. This will be only condition. If first if condition, if there was a train at R station, then it will return true.
Okay, so option A is correct.
Yes, sir.
Okay, what about option B?
From false if the station is starting from the station. No, sir, it is false.
Okay, option B is false.
Yes, sir. It is not correct. Option.
So, do you remember what we were saying about I and J?
Yes, sir. I is column and I is row and J is column.
Yeah, so in terms of station, I was what? The departure station?
Yes, sir.
I was
And J
our
was
departure station, and J was arrival station,
arrival.
right?
Yes, sir.
So if we in line number third, we are saying A of R of station.
Yes, sir.
What does this mean?
From departure station.
So the departure station is fixed, right?
Yes, sir.
We will start from any station, but we will depart. The departure station will be your given station.
Yes, sir.
So if that is true, then we are returning true, right?
Yes, sir. Yes, sir.
In the option, it is saying starting station is STN. That is incorrect, right?
Yes, sir. It should have the ending. Instead.
Yeah, that is like if we had that some proc returns true if station STN is the ending station or arrival station for train, then we could have said that this particular option is correct. But right now, this is incorrect, right?
Yes, sir.
What about option B? Is it correct or incorrect? For option B, you
Then
have to check this particular line.
it will be
Line
asked us
number 5.
which station is going from the will turning false.
Is this correct or incorrect?
C is It should have the ending station for the train to return false.
Option B, this
Yes,
is
sir.
also false.
Yes, sir.
Option B is not false. How is it false? See, in
This is the
line
railway
number
station,
five,
na?
we are doing this, right?
Yes, sir.
We are fixing the
Station.
departure station.
Yes, sir.
The first index is
And
for departure
departure
station
station.
or starting station. Okay, and we are
Yes,
saying
sir.
the train can go to any station, right?
Yes, sir.
The
Yes,
departure
sir.
station should be STN, and
Yes, sir.
the train can go to any station S1, S2, S3. So
Okay.
in that case, we are returning false. So that is the same thing, no? We are saying
Yes, sir.
over here.
Yes, sir. Station is the station is fixed.
Option
Yes,
B,
sir.
is it correct or incorrect?
Yes, sir. Then it will be correct.
It is correct. Okay. For the, like these type of questions, you have to be very careful about rows and columns. What is representing rows? What is representing column?
I even got confusion in this row and column. It is in station of C and R of station.
So C is representing columns that you have to remember. And when we use this kind of format for stations, we have
Yes, sir.
already like done, I think, 3 or 4 questions, right, previously.
Yes,
And
sir.
in each question, the ith index was representing your source station, departure station, starting station.
Okay.
These are the terms. Okay, so that is your first index, and J is your final station, or there are many jargons
Uh,
we can use. Okay,
uh,
so that is your
yes, sir.
ending station.
Yes, sir.
Now, when we are saying that we passed a station, we passed some station, that STN is fixed, right?
Yes, sir.
We passed some station, so it is fixed. Maybe Mumbai. We passed Mumbai. So that part is fixed.
Yes,
Now,
sir.
if we are saying that we will check A of R of Mumbai, if STN is not clear, just maybe remove this and write Mumbai or some station name that you are familiar with. Now, if we are saying this, then we are fixing Mumbai, right?
Yes, sir.
So we will fix the column. We will fix the column. So Mumbai is one of the columns. So we have multiple columns, C1, C2, and Cn maybe. We fixed Mumbai and we checked all R. Okay, so this is some, let's say, some data in R1 of Mumbai, some data in R2 of Mumbai, some data in R3 of Mumbai. Okay, so we are
Yes, sir.
doing this in your line number 3. Same thing when we do in line number 5. Since we are fixing our row, since we are fixing our ith index, we are fixing our row. So STN or Mumbai, you can say if you want. So Mumbai is this, okay, and we have some distance D1, D2, and D3. Okay, now we are iterating over our columns, right? Because column is not fixed.
Yes, sir.
This you have to remember, and if you solve good amount of problems, good number of problems of like these, then you should be able to figure this out. Okay. So option A
Yes,
was
sir.
incorrect. Option B was correct. What about option
Yes,
C? Is it correct or incorrect?
yes, sir. It will be correct. It will return the true if the station is ending for the train.
So some proc returns true if a station is the ending station. So that we are getting from the if condition
Line
over
number
here.
3.
Okay.
Yes, sir.
So option C is correct. What about D?
It will return the false for the ending station. It will be correct.
This is
Correct for the line number 5.
line number again. Line number 5 is saying we are fixing the row. That is
Yes,
your
sir.
starting station.
Yes, sir.
read this option and this option. They are identical, almost identical. Just one change is one thing is different.
One is returning true and another is returning false. If C is correct, then D
Okay,
is
so if you
incorrect.
are saying that C is true, then D can't be true, right?
Yes, sir. D is incorrect.
D is not true. Okay.
Yes, sir.
What about option E? Is it correct or incorrect?
Intermediate station. Intermediate station. Sorry to incorrect.
This is incorrect. Okay. What about F?
It is also incorrect. It is checking for the intermediate station.
Some proc returns false if station is an intermediate station on train's route.
We are not
So
checking intermediate station, no?
that was when we were creating the our matrix, right? Right now we are
Yes,
just
sir.
iterating over the matrix, not basically doing the operations on that particular matrix. We are picking the items, but we are not directly doing the operations on the matrix.
Yes, sir.
For this, you have to check the code. Okay.
Yes.
For F, you have
Mm,
to check the code whether basically this particular thing is correct or not. So let's try to go through the code once again, and we will try to figure out whether this particular option is correct or incorrect. Okay. I'm not
yes, sir.
saying it is correct or incorrect right now. Option E, we may find again that this is either true or false. But right now,
Mm,
this is not true because we are just returning true only when this is happening. Okay, the
yes,
station
sir.
is your what ending a station. Only in
Yes,
that
sir.
case we are returning true. So that's why we are returning this. Okay, 1 second. Give me 5 minutes.
Very clear question, actually.
Okay. I hope I am audible. Can anyone
Yes, sir.
confirm?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
So option F.
Yes,
Uh, option A, E is incorrect, right? You got that, or
yes,
do you
yes.
want
E
me
is
to explain
incorrect.
again?
No, no, sir. I understand why E is incorrect. I am confused in F. Why it
Okay.
is returning false?
So for F, like over here, if you see, we are returning false only over here, right?
Yes, sir.
And there is one more case over here. We are returning false. Okay.
Mhm.
So this part is not responsible for your option F, right?
Yes, sir.
Because if
Okay.
R is not in rows of A,
Yes, sir.
then we are saying this thing. Okay. If we don't have some R in your rows of A, then we will
Yes,
move
sir.
to this. Okay. After iterating over everything, and we don't return either false or true, then we will return false. But that won't happen because we only have two situations where we are returning something. One is over here, so we are returning false, and another is over here. So inside your if block, the top level if block, if we go inside that, we will always return something. Okay.
Okay.
So the outer false is not responsible for your option F. What about the internal one? So we are saying that if some station
Yes, sir.
STN,
Mhm.
okay, is a departure station. Sorry, not departure, arrival station for train. Okay, for
Okay, sir.
train. Let's say, just for not having any confusion, I'll say instead of train, I'll say T1. So
Yes, sir.
if STN is your arrival station for T1, okay,
Even. Yes, sir.
then we are iterating over all the columns of A,
A.
okay, and
Yes,
then
sir.
we are checking whether that particular train, that is T1,
Is going
has
from station to C.
yeah, is going from station to some
C
station,
station.
okay, some station C, maybe S1, S2, and okay.
Okay, sir. Okay, sir. I understand. If it will return true, then the F option will be correct. Because then the STN station will be the intermediate station.
Yeah, this station can be your intermediate
Yes, sir.
station, right?
Okay, yes, sir.
Right.
I now understand the code. Like in the first if condition, it is checking if there is a train ending at STN. In the second if condition, it is checking if the train is ending at any station.
Okay.
Am I correct?
Is this clear? Yeah.
Yes, yes. I am clear now. Clear now.
Okay. Okay. So if like for others, if this is not clear, what is happening is like we are starting from some station. Okay. So let's say this is for your line number 3. So we have some station. Okay. From this station, suppose we are starting, and we don't know which station is it. So we are checking all the stations, and if the arrival station is STN, let's say your train T1 is using S3. Okay, S3. From S3 we are reaching over here. Okay, then we are doing the same thing on all the columns, and inside the columns we are checking this part. Okay, now we are saying that STN is your source station for the internal if block, that is line number 5. We are saying that STN is some internal the source station, and from this source station we are going to some other station, that is yours represented using C. Okay, that is we are representing our using C. So if we do this, then STN automatically becomes what? your intermediate station, right?
Yes,
So
sir.
this is what is happening.
Just get confused in R and STM to understand which one is the starting and which one is ending.
Yeah, that for that you have to be a little bit careful, and you have to keep the things in mind that
Only that part is confused me.
yeah, that part is confusing. That part is confusing. Well, it is confusing because we are not using an actual station name or train name, so that's why it is
So
confusing. If like
you
instead
just
of using
written R of station that it confused me.
yeah, so instead of
Just
using
simple.
STN, if we could have just used S1 or some station name,
It
then
will be easy to understand.
yeah, I got that. So if you find this type of problem, then what you can do is you can just in your copy or somewhere you can just copy the whole procedure, write the whole procedure, and instead of using this variable or this thing, you can directly use either S1, or if it is a train, you can use T1 or some number for the train, maybe 1 2 3, something like this you can use, and then proceed. Okay.
Yes,
Okay, so F is correct. E we
yes, sir.
decide E we discarded because that was incorrect. What about option D? I think D was also incorrect. C was
Yes,
correct.
sir.
B was
Yes,
also
sir.
correct, and A was incorrect. What about
Yes, sir.
option G?
Sir, it is incorrect. If there is no train on the route, then it will be returning false.
Uh, okay, okay. So G is again incorrect. Do we yeah, we have another option. F. Sorry, H. What about H?
Sir, it will be correct because in third line we are checking if there is a train on the route or not. If there is no train on the route, then it will return false. It is correct.
Okay, so B was correct, then F was correct, then H is also correct, and I think one more was correct. C.
Yes,
Option C was also correct. So C,
yes,
B,
sir.
F, X. Okay.
Yes, sir.
Any doubt in this one?
No, sir, no, sir. It's clear now.
Okay. Let's move to the next problem then. This is again a comprehension question, and this is related to two questions. First, we will go through the comprehension, see what is happening, and then we will basically do question number 6 and 7. Okay. So let's read the statement first. Assume there are n trains in the trains dataset indexed from 0 to n minus 1. Consider a graph with stations as nodes. There is an edge from station I to station J if and only if there is a direct train from I to J. The graph is represented by a matrix direct such that direct of ij is equal to 1 if there is an is from I to j and 0 otherwise. Okay. Assume that direct has already been computed and direct is non-symmetric a matrix. Non-symmetric matrix. Station j is reachable from I if we can find a non-empty, that is find we can find a non-empty sequence of trains that take a passenger from I to j. In other words, j is reachable from I if there is a non-empty sequence of edges that connect I to j in the graph. The following pseudocode computes a matrix B of identical dimensions as direct, such as B of ij is equal to 1 if and only if j is reachable from I. All other entries of B are 0. Okay. So are you clear what is direct and B representing?
Sir, it is checking if there is a train from going only from I to Z.
Yeah, direct is your direct trains basically. Okay. So if
Yes, sir.
station S1 has a train which is connecting it directly to station S2, then we
Yes,
will have 1,
yes, sir.
otherwise we will have 0,
Zero.
right? So that is your direct, and B is basically your reachable station. Okay, we are not considering that it is a direct connection. We may have multiple intermediate stations. That is totally fine.
Yes,
But
sir,
if
if the train is going there.
yeah, if a train is starting from S1 and it is reaching to S2, no matter
Yes,
how many intermediate stations are there,
yes, sir.
then it will have 1, otherwise it will have 0. Okay,
Zero.
is this clear?
Yes, sir.
Okay. If this is clear, then this is one thing. What is N? You have to tell. What
Sir,
is
it
N?
is length between directed train between two stations. In how many steps
Length
it is going? If it is
length
reaching
of
one
keys
step,
of direct length of keys
hello,
of direct is what?
uh, no, no edges between two nodes.
Edges between two nodes.
Yes, sir. It will be.
Not edges between two nodes. That is incorrect.
I think I'm too detailed. I think
Direct is what?
um, direct is only one-sided from I to J.
Direct is a matrix, right?
Yes, sir.
Which contains 1
And zeros.
and zeros. Let me say this is suppose for this one it will be 1 because this is S1 S1. This is S2 S2. Sorry about the handwriting. Okay. So if S1 is connected to S2, then it is what?
One.
Again 1,
Yes,
otherwise
sir.
0. Okay. So
Yes, sir.
let me add 0 for all the others except the diagonals because they are the same station, so they are always connected. Okay.
Yes,
So this is your direct kind of.
yes.
Okay. Now we are saying keys of direct. So keys of direct is what?
S1, S2, S3 are the keys.
Right?
Yes, sir.
Now if we do length of keys of direct, that is number of stations, right?
Yes, sir. It is connecting.
No, not connected. Number of stations. Only number of stations. How many stations are there?
Yes, sir.
How many eyes are there? Okay.
Okay, sir.
So N is basically your number of stations. Okay. N is this. B we have initialized. So this is basically initializing B, and we are saying B of RC is equal to direct of RC. Okay. So this we are just initializing B. Can anyone tell why line 5 is correct or incorrect? First, whether it is correct or incorrect, you have to tell. And if you think that it is incorrect, why? If you think it is correct, tell me the reason for that as well. You are saying B of RC is equal to direct of RC. Is it correct or incorrect?
Yes, sir. It is correct.
It is correct. Why?
It is taking. It is creating the matrix B from the matrix direct.
And why do you think that is correct?
Mm.
Like previously, when we created a new matrix, like in one of the questions, when we created matrix A,
Yes, sir.
we assigned empty dictionary, right?
Yes, sir.
Why do you
And
think using the element from direct, that is 1 or 0 is correct. We could have maybe used zeros for all the cells. We are not doing that. Why?
because we already have the direct matrix,
Yeah.
and in the
And
previous question we are creating the matrix from the given data in a tabular form.
so, like, if we say direct of RC, that means
Yes,
what?
sir.
Some station S1 is directly connected to S2, right?
Yes, sir. Yes, sir.
So if we do B of RC is equal to direct of RC, and direct of RC is already telling that these two stations are connected. So if S1 is this, S2 is this, okay? Again, S1 is this, S2 is this, the second one. So if we are saying that S1 is connected to S2 in our direct matrix, that means S2 is reachable from S1, right? That means if they are connected, that means directly connected, that means S2 is reachable from S1. Is this a
Yes, sir.
statement correct or incorrect?
Yes, it is correct.
It is
If
correct.
there
So
is a
that's why
direct
we are
link, then
directly,
S2 will be reachable.
yeah. So if they are directly connected, that means your destination station, your ending station is reachable from your source station, right?
Yes, sir.
So
Yes,
we can
sir.
use that. So that's why we are using this particular thing. Okay. So now the direct stations are already having one in your B. So when we initialize B, we already filled one for direct stations, directly connected station. Now we have to check for hops, that is the stations which are connected, but not directly. There are some n number of intermediate stations. Okay. So we have to check that, and based on that, we will create our basically we will fill our dictionary, sorry, matrix. We'll fill the remaining ones in our B matrix. Okay. So now we initialized hops is equal to 0, and we are saying while hops less than n minus 1. Why we are saying n minus 1?
Because we
Why?
are counting from 0 to the n
Yeah,
number.
yeah, n is basically number of source stations, so we
Yes, sir.
can't have
Uh, and
hops
because we
greater
are counting
than,
from 0.
yeah. So hopes can be greater than n minus 1 if we are starting from 0, right?
Yes, sir.
Okay, so that's our breaking condition. Now over here we are saying one more hop B, and then we are increasing the hops. Now
One,
over here we have a procedure, and in the procedure there is some code missing, and I think in either question number 6 or 7 we have fill that code. And if you have any questions in this particular thing, then we can discuss right now. If not, we will move to question number 6.
there is one more hope checking if there is an intermediate station or not.
It's so basically in B matrix, right now we have 0 and 1s, right?
Yes, sir.
This will be 0, 1. This will also be 1. Let's say we have 1, 0, 0. Okay. So this is coming from where? Your direct matrix, right? From your
Yes,
direct matrix, this you have already built. Now for the remaining zeros, that is this one, and this one, you are checking whether you can switch maybe one or two more based on your hops, right? If some S3, so from S3, if you are able to reach S2, in maybe using in the route, suppose the route is like this. From S1, S3, you went to S1, then you went to S2. So S2 is reachable from S3, but currently, since we have used the direct matrix directly, so this position is 0. Okay. So this should be 1 in B. right? Because this is reachable. S2 is reachable. So now to handle that, we have a procedure, and this procedure will make some modifications in B, and it will finally return B, and we are basically assigning that to our previous B. So it will make some modifications in B. So that we will check in our question number 6 and 7. But other than that, if everything is clear, then I'll move to question number 6. Any doubt in any other part of the question or comprehension?
No, sir.
Okay. If there are no doubts, then let me move to question number 6. So the pseudocode is incomplete. Select the correct code fragment to complete it. It is an MSQ. Again, this is an MSQ, so we may have multiple correct options. Now, okay, so option A. What do you think? Is it correct or incorrect?
Sir, I think it is correct. Because in first if condition, if we there will be direct route from R to C, it will exit the loop. It means there will be no hop. Am I correct?
Okay,
Hello.
uh, if RC
If
like
there
B of RC is equal to
one,
1, then we are
isn't
sorry.
if there is two stations, suppose there are two stations and they have a direct route, no intermediate station, then hop will be zero.
Yeah, for direct hope will be 0. Yeah.
Yes, sir. So this option will be correct because in second if condition it is checking if from R to K there is a route and K to C there is a route, then
R to C is the 2.
R to C 1.
Yeah. So
The hop will
A
be
look,
1.
we are not uh, counting the number of hopes. We are
Just
we are
checking.
not counting the number of hopes. In B, we are just saying that some Sj is reachable from Si. If
Yes,
it
sir.
is reachable,
Yes.
then we will
Then return
assign 1.
1.
Otherwise, we will assign
It
0.
is 0.
Right.
Yes, sir. So A will be correct.
So yeah, A is correct because over here, what we are checking whether there is for some station S1 and some station S2, if there is like for those station, if B has value 1, then we will directly exiting the loop. We will directly exit the loop. Otherwise, we are checking
We
if
return
there is
1.
an intermediate station or not between them. If R is connected to K and C is also connected to K, then we are saying that R is connected to C. Okay.
Yes, sir.
So option A is correct.
Yes, sir.
Let's move to option B. What about option B? So we have total 3 more options. What about B?
Sir, correct, but it is missing the. It is not taking the direct route between R to C.
That is fine. No,
If then it will be correct, sir.
it is correct. So
Yes,
basically, we
sir.
are just changing one thing, and that one thing is based on this part, right? So B will like for if some position, let's say this particular index, if initially while initializing B, if this was 1, based on this particular thing, it won't change, right? This won't
Yes,
change.
sir.
This will only change one of the zeros, right?
Yes, sir.
Yeah. So suppose we have from S3, S1 is connected. Second, yeah. From S3, suppose S1 is connected
Yes, sir.
and we are checking whether S2 is connected to S1 or not. If initially this was the case, S3 is connected to S1 and S3 is connected to S1, okay,
Yes, sir.
and S1 is connected to S2. We are checking for maybe this position. We are checking for this position, and S1 is connected to S2. Okay,
Yes, sir.
S1 is connected to S2. So we are basically checking for this position. So using this part, initially this was zero based on our direct matrix. This was zero, but if
Yes,
we use this, this will change to one because
one.
in the in the matrix we are saying that this part is there and this part is there. Okay, so
Yes, sir.
based on these two parts, we are saying that this part will be one.
Mm.
Okay,
Yes, sir.
is this clear, or do you want
Yes,
me to
sir. Sir.
explain this again?
No, sir. Clear, clear.
Okay, what about option C?
Sir, it is incorrect because it is checking the K in rows.
It is doing the same thing, but it is using rows now. So this is also
R is
correct.
already in the row and it's checking again in row.
Yeah. So this is again correct.
Yes,
If we do using rows, that will be correct. If we do using columns, that will also be correct. So this is again correct. What about D?
it is not checking the intermediate station.
Yeah, it is not checking for the intermediate station. So that is why D is incorrect. So A, B, and C are correct, and D is incorrect. Any doubt in this one?
Some B, K is checking in row, then we are assuming that R will be in column.
Which option are you talking about?
Option C,
Option C. For each k in rows of B.
then R will be checking in which column.
So if you are doing this part, okay. So if you are picking one of the, so R is over here. You are saying no.
Yeah, yes, sir.
So R will represent what? We have fixed one of the rows. Okay. So this is your column. This part is your column. Then we are checking for. We are basically like if you, let me show this again. Keep this particular diagram in your mind, it will be clearer. So if we have these two things, S1, S2, S3, if we have these two things, so it doesn't matter where you are picking from K, where you are picking the K from, because in rows we have the same stations. In the columns, again we have the same stations, right? Is this clear?
Yes, sir. Actually,
So K is basically in the first iteration, K will be your S1, right? And you are doing R is a variable, like in your second line, R is a variable and S1 is fixed. Your column is fixed, so you are checking this row,
row and
right?
column are different, then this will be incorrect.
Can you speak a bit louder? I
Yes,
didn't
sir.
get you.
I'm saying if we suppose that the row and column are different, then the option will be incorrect.
Yeah, in that case, this option will be correct. This one will be incorrect.
Yes, sir.
Okay.
Okay, sir.
Any other doubt?
No, sir.
Okay. So question number 7 then we have here we are given a graph and n is 5 over here. What sorry, matrix B is computed using the above pseudocode. What is the value of sum after executing the following pseudocode? So we had a pseudocode in line number, sorry, we had this pseudocode, right? And we calculated B using that pseudocode. Now we have a graph given, okay? And for this particular graph and that particular B, we have to tell what will be the value of sum.
We, sir, how will we assume that which value is in rows and which one is in column?
Let's first try to create a B matrix, okay? Let's try to first create the matrix itself. Then we will check whether, then we will check what we are getting for sum. Oh, and one more, total 5. 1, 2, 3, 4, 5. This is our 0, 1, 2, 3, and 4. Okay, same thing over here as well. So let me write that. 1, 2, 3, and last one I am writing over. Okay.
Yes,
So
sir.
0 to 0, is it connected or not? It is
Connected.
connected, right?
Yes, sir.
What about 0 to 1?
Connected.
0 to 1 is connected, so we will write 1. 0 to 2 is also connected, we will write 1. 0 to 3, 1.
One.
And 0 to 4 is again 1,
One.
right?
Yes.
What about 1 to 0?
Not connected.
We are not talking about direct connections over here. So 1 to 0, is it
One.
connected or
One. Connected.
it is
Connected.
connected, right?
Yes, sir.
What about 1 to 1? 1 to 1 is also connected. What about 1 to 2?
Connected.
1?
Connected. Connected.
Seems like all of them are
All are
connected.
connected. Yes, sir.
Is this correct?
Yes, sir.
Okay, so this is our matrix B. Now we are saying rows of, so we are picking R. R is what?
Rows.
Initially it is our, this row, this particular row. Okay, so we are
Yes,
picking
sir.
this row,
Yes,
and
sir.
from that row, we are picking one column at a time. So each cell we are picking basically. So
Yes,
first
sir.
we will pick this particular cell, then we will pick this particular cell, and so on. So this is for 0, then we will move to 1. For 1 we will pick this, for 1 we will then pick this, and so on. Then we will do the same thing for 2, and so on. So basically we are picking all the what? All the cells one by one.
Yes, sir. Yes, sir.
And we are summing the cell value. Whatever value
Yes,
we
sir.
have in the cell, we are just
Yes.
summing all the values. So what should be the answer?
25.
25. Okay,
Yes.
that's the answer. Clear?
Yes, sir. Yes, sir. Clear. Clear.
Okay.
Sir, thing I want to ask. The connecting line that are drawn in the figure have the arrow. So how we assume that if it is directed or not? Because in the image it is drawn an arrow. So that's why I think it is the directed.
This is directed. This is directed. But when we said that 1 is connected to 0, so it
Yes,
was
sir.
not this path. It was
Okay.
not this path. We said that we went from 1 to 2, then 2 to 3, 3 to 4, then 4 is connected to 0.
Zero.
So it was this path.
Yes. Okay, sir.
Okay.
Okay. Okay.
Suppose this line was not there. In that case, 1 was not connected to 0.
Oh, yes, sir.
Any other doubt in this one?
No, sir. No, sir.
Okay, then let's move to the next question. Again, this is again a comprehension, I believe. The two questions are related to this. The following pseudocode is executed using the trains dataset as discussed in the lecture. Assume trains is a dictionary with train number as key, mapped to a list of stations which that train runs through. Okay, example is given, so that should be clear. In this example, the train with train number this starts from Bhubaneswar and reaches New Delhi via Balasore, Agra, Varanasi, and Kanpur in the order. Let com num L1 L2 returns the number of common elements between list L1 and L2. Observe the following pseudocode and answer the given question. So first we need to check what is happening in the pseudocode. Okay,
Yes, sir.
so let's try to break it down. What is happening over here? So we have initialized two variables, I and index. Index is our dictionary, some dictionary. Right now it is empty, and I has value 0 right now. Then we are doing this. What will this do? What will index contain
One second,
after
sir.
executing those three lines?
The index, the number of stations.
Index of I is equal to index of t is equal to I.
I.
What is what will be the value of index at the end of executing this particular thing? Line number 3 to 6. So we are saying that index is equal to in key what we will have in key what we will have
Bhubaneswar.
not Bhubaneswar. We are saying keys of trains, no? So keys of
I
trains
thought
is what? The train number.
12, 28, 1.
Yeah. So for that particular train, this will be the thing,
Yes, sir.
and it is mapped to what?
I.
I. Right now, I is 0, right?
Yes, sir.
In the next
Yes.
iteration, we may have some other train. We may have some other train, maybe this train, and there will be some index for that train. So we are basically creating indices for the train. For each train, we
Yes,
will
sir.
have some index. Is it clear?
Yes, sir. Yes, sir.
Okay, that is clear. Can you tell me what will be the value of n and yeah,
And
what will be the value of
key
n?
of indexes length. It will return the. We are just
Number
checking the
of
length stations. How many stations of the store in that key?
index is not storing in stations. Index is storing what?
Train number.
Index is storing trains, right? Train number.
Yes.
So if we
Check.
do keys of this, we will get all the train numbers, right? And if we do the length of that, so it will be number of trains. How many trains are there? Correct? Is this clear? Or do you want me to explain again? Is this clear? You're not audible.
Yes, sir. Clear. Clear.
Okay. So n is basically representing number of trains. Okay. Then we have initialized CSTN. Okay. It
Yes,
is a
sir.
matrix n cross n. So let's say maybe 3 cross 3. So it is an empty matrix. For
Sir.
each T1 in keys of trains, for each T2 in keys of train, if T1 not equal to T2, we are doing this. So what will CSTN, what will each element of CSTN represent?
Common trends.
Common elements between L1 and 2.
Yes, sir.
Common trains.
No, it is saying the train is not common in if condition.
Yeah. So line number 13 is if T1 is not equal to T2. Yeah, that is correct. What will this will be 0 basically. This will be 0. So initially when we initialize this all will be 0. Okay.
Yes, sir.
So
Restore the train.
these two are equal, so this won't change. So
Yes,
your 0 0 value will not change. The element at 0 0 won't change. But what about this? What will this contain?
0 1.
Yeah, this element. What will this contain?
T1
When
and T2 train.
not T1 and T2, you are doing com num of L1 L2.
Common elements between the list L1 and L2.
So what will it contain?
The element in L1 and L2.
L1 is what? Trains of T1.
Yes, sir.
Trains is this dictionary, and T1 will
Yes,
be
sir.
one of your train numbers, right?
Train number. Yes, sir.
So if you do trains of T1, it will
Yes, sir.
return all the stations
Yes, sir.
which are visited by train T1.
Yes, sir.
Trains of T1 if we are doing, so it will
Yes.
represent what?
All the stations that the train T1 visited.
Yeah, so S1, S2, and so on, right? Same
So
thing
it
for
will
T2.
yes, sir. So it will store the common stations.
It will store the
Common
not
station.
common stations, number of common stations, right? Over here it is written that com num of L1 L2 stores the number of common elements between list L1 and L2, right? This is clear. Okay, if this is clear, then what will this contain? What will the element at this index contain?
Which index you were asking, sir?
This one,
12 to 52.
not T2. Like these are representing trains. Okay,
Yes,
so
sir.
these
I
indices are
understand.
currently representing trains.
Which index you were asking?
This one, my screen is visible, right?
Yes, sir.
I'm asking
Visible.
about this one.
Acha, 0101.
Yeah, 0 1.
Yes, sir. Number of one.
It will basically contain the number of common stations for train with index
T1 and T2.
0 and 1.
1.
Okay,
Yes, sir.
so these are basically train numbers. Just for example, I have used like single digit number, but when we create CSTN in actual format, we will have your actual train numbers. Okay,
Yes,
so
sir.
5
Yes,
digit
sir.
train number. So what is CSTN? It is clear, right?
Yes, sir. CSTN is the matrix and it is storing the
Common
stations.
number of common stations between two trains.
Yes, sir.
Okay, if that is
Yes, sir.
clear, let's move to question number 8. If
Yes,
CSTN
sir.
of ij is 0 for I not equal to Okay. Then which of the following statement can be concluded?
There is no common station on the route of a train with I and J. Common station होंगे ही नहीं, sir.
Okay. Option which
C,
A,
C,
B,
C, C.
or
There is
C.
no common station. C, C. Common
Okay.
stations.
Okay. That is correct. Why not option A?
We are not checking the route between I and J.
We are checking for direct connection, right?
No, so we're checking the CSTN matrix is storing the number of common stations. Uh,
Okay. Yeah. We are
so
not checking for it. Yeah. Yeah. Correct.
if there is no common station, then it will be 0.
Right. Okay. So option C is correct. Option
Yes, sir.
A, B, and D are incorrect.
Yes, sir.
Option 9 is it related to that one?
Yes,
Assume
it
we
is
start our
related.
journey using a given train T. Now consider the following procedures. They should return true when it has at least one common station with all other trains. Okay, so do something is the same procedure that we used over here. Okay, we are
Yes,
using
sir.
the same thing, and it is returning two things that you have to keep in mind. First is your CSTN matrix, and second is your index dictionary. Okay.
Yes, sir. Uh,
Now consider the following procedures. They should return true when it has at least one common station with all other things. Okay. T is your T is your constant train. So T we have to fix. If you want, we can use T1 for that. And trains is our trains dictionary, which was mapping train number, maybe T1, to all the stations it was visiting, right?
yes, sir.
Okay. So option A is this. How many options are there? There are four options. Let's try to first check which option is correct and which is incorrect.
Found
Option A,
0.
is it correct?
Option A.
You can go through the pseudocode once. And once you are done with that, then you can move to the options. Let's-
Option 1, sir, I think incorrect because it is not checking the common stations.
One is correct.
Incorrect, sir, I think, because it is there is no condition to check and return true.
Over
If
here it is returning true, and
if
over
the
here it
for
is
yes, sir, it is correct. If there is if CSTN matrix is 0, it means there is no common station. Then it is returning false.
okay.
But sir, the return to statement is outside for for loop.
Yeah, that is fine, no? Like suppose first you are trying to iterate, okay? If you
Yes,
found this particular condition, if you found that there is a row and column for which this particular condition is correct, then you will return false, okay?
sir.
If
If not,
if you don't find this condition, okay,
yes, sir.
then you will complete your iteration, you will do everything, and then at the end you will return True.
Yes,
So
sir.
you just need to check whether this particular thing is doing the correct thing or not.
I think the first option is incorrect because I think the return true statement is the outside of the for loop. That's right.
That is not the reason for option, sorry, your pseudocode or procedure one to be incorrect. That is not the correct reason for that. So there are two things. Suppose you are saying that if true, then I will return 0. Okay. Else I will return 1. Suppose this you are saying. Okay. Instead of doing this particular thing, and suppose if you have a for loop outside this. Okay. So there are two returns right now inside your this thing fault. Now instead of having those two things, you could just say for loop is over here. Then you are saying if I am seeing false, then I will return 1. If I don't see false outside the for loop, if I don't see that thing, then I will just return 0. Both are correct. Okay,
Yes.
both are correct. Same thing when we check for even numbers, we do something similar, right? We try to iterate over all the elements. Suppose we are checking whether some number n is even or not. Okay,
Yes, sir.
so we will start from 2 to we'll go to for each, let's say for each from 2 to where n minus 1,
Yes, sir.
and if n is, let me use remainder itself. If remainder of n comma I, let's say we are using I, sorry about the syntax. Let me know if the
Yes,
like
sir. It is
syntax.
not problem, sir. It is okay.
Okay. So if we say remainder of REM, remainder of this thing, and if it is equal to 0, okay, we
Yes,
are
sir.
saying that if this is happening, we return false, right?
Yes, sir.
Or maybe even you can say, okay,
Yes,
you
sir.
can say not even. Sorry, prime we are taking, not even prime we are taking.
Yes, sir.
So in that case, we will return false because some I inside this range divided the given number.
Yes, sir.
Okay, so we are returning false. After completing this for loop, if we don't find any number which exactly divides n, then outside the for loop we can say return true, right? If we don't
Yes, sir.
find a number, we can just say that the given number is prime.
Yes, sir.
So this part is just checking for the negation condition. If we find that negation condition, then we will return false. If we don't find that negation condition, that means the whole thing is correct.
Yes, sir.
Okay.
Yes,
Now
sir.
check procedure one and procedure two, and tell me which is correct.
Sir, procedure 2, I think, is incorrect because
Procedure.
in first if condition, It is checking the common station, but in second condition, it is checking if the number of stations for the any train is
Count is equal to length of
to
station.
return the true in second if condition.
Second if condition is basically saying count is equal to length of keys of train.
Yes, sir.
How is it? Wow. How is it incorrect?
Because sir, we are not checking this thing to return the true. We have to check the common station
We have to check the common station.
to
We don't
return
have to check the common stations. We have to see. You need to read this again. Consider the following procedures. They should return true
to
when
if at
it has at least one
least
common station
yes
with
sir.
all other trains.
Yes sir.
Okay. So T1 we have picked, which is in the question it is represented as T. Okay.
Yes sir.
So we have this train and we have to check that all the trains in this particular dictionary. So we have some trains over here, T1, T2, T3, and so on. Okay. So we have
Yes
to
sir.
check that this picked uh, train has common stations, at least one common station for all these trains or not. So
Yes
that we
sir.
have to do. Now over here,
Yes
what
sir.
we are doing, we are
We are checking
checking
common station.
common stations.
Yes sir. This
Okay,
part is correct. Um,
and now we are incrementing count. So what
yes
will
sir.
count
This
represent?
count represent the number of trend through which T is sharing common station.
Okay, this part is clear, right?
Yes,
So
sir,
number
this
of
part is
trains.
clear. I'm saying about the second if condition.
Now over here, what we are saying?
Comparing the count with the length of keys of train.
So length of keys of trains is this list only.
Yes, sir.
So if
So suppose if there is an train which does not share the common station, then the count wouldn't increment. Then the count wouldn't be equal to the length of keys of train.
yeah, if that is not the case, we are returning false, right?
Yes, sir.
But if the count is equal to the length of keys of trains, we are returning true. That is the same
Yes,
thing,
sir.
right?
Yes, sir.
That is the same condition we have we are given in the question.
Yes, sir.
So this particular pseudocode is correct. Question sorry pseudocode two or procedure two is correct. It is not incorrect.
Yes, sir.
What about this one?
Yes, I understand.
This is correct or incorrect?
The,
Procedure one.
the return true. It is correct, sir. If the false
This is
condition is
also correct
checking for the
because we are returning false only when
only when
there is
there is no common station.
yeah when there is no common station. Then
We
we
are
are
returning
returning
true.
false.
Otherwise, we will
Otherwise, we
return
are
true.
true. Okay.
Yes, sir.
So both the procedures are correct. None of them are
Yes,
incorrect.
sir.
So the options are which of the above procedures works as intended. Option C. Option C is correct.
Yes, sir.
Okay. Both procedures work correctly. Is this fine or do you have any doubt in
No,
either of
sir.
the procedures?
No, sir. It is
It is
fine.
clear, right? Okay.
Yes, sir.
Okay. So that's pretty much it for today's session. Do you have anything you would like to ask? Any question you would like to ask?
No, sir. Uh, thank you very much. I hope you will not get irritated by me.
No, no, that is fine. Okay. Thank you for joining.
Okay, sir.